This is the lab where we determine the energy of a rolling ball. Being online, it's hard to get the correct time for these, so I'm going to give you some numbers that I've used on this lab. But first, let's go procedure number 1. Make a hypothesis on what will happen to the energy as the ramp height is increased. We can write this down below. To show you what this looks like, here's our ramp, and what we're going to do is add an extra book and then a third book. So that's how it's going to get higher. So pause the video, write your hypothesis. Okay. Some data we got to get before we can do anything else is the mass of the ball, and we're going to put that on the balance. And you can see that the mass of the ball is 28.18 grams. Now, remember, we got to convert grams to kilograms. The next thing we need is the length of the ramp. This is important that we have a starting point, which will be our blue line, and we measure it all the way down to the end of the ramp. So we'll put a meter stick on there. Again, starting at the start point, moving our way down all the way to the end. And again, record that. That is in centimeters. And then change your centimeters to meters. Now, I have the times written in for you, but let me do a demonstration on how this goes. So what we would do is start the ball right there, and we would let it go and follow it all the way down, boom, to the end, and stop the time right there. And we would get those times. Now you got to calculate the average of them, and my bad writing, that is 2.70, but you also need the height of the book. So let's look at the height of one book. Of course, we are doing it in centimeters. You convert that to meters. Enter that score, or the data into the height of one book. Now let's look at the height of 2 books. Go ahead and enter that score. Excuse me, measurement, not score. And last, with 3 books, and put that measurement in there. Now you have all the data that you need. Now it's time for some analysis. Now, I think if you read through, it's pretty self-explanatory, except for this one spot. Average speed, it says equals length, and it looks like minus distance. That length is the distance that we have. So that distance, it's not minus, was the number you got there. So distance divided by your average time gives your average speed. I want to see your work here, so put your numbers. Go ahead and finish all this. Good luck. We'll see you later.